Maybe not complete presentation, but Marcel would like to tell us about something about his own IoT project. So
should I talk English or sorry?
French one?
Huh?
French one?
French?
I think English.
English? Okay. So I didn't really.
thank you very much.
Okay, thank you. So I didn't really prepare a presentation. I would like to talk about two things. One thing is who I am, what I've done, what I'm working on, and the other thing is more or less about trying to kick off a initiative of IoT gateways in Bratislava. So I'll start with me. My name is Marcel. Some of you might know me. I've started a project called LavaNet. It was a free community wireless network. It was started about 12 years ago. It was quite popular then. We had lots of hundreds of users using the free network. It was a free internet access network built on Wi-Fi 2.4 and 5 gigahertz network. That was during my high school years. Then I went to Britain. I spent a couple of years in Edinburgh and Aberdeen in Scotland. So I started my sort of doing more project over there. So the project here kind of diminished over the years. In between then, I've finished a product design degree. So I'm a product designer. I'm not an IT. Well, I do IT professionally. I'm not academically educated in IT. So please bear that in mind when you're talking very hardcore IT stuff. For a living, I do Linux and Unix and DevOps stuff. I do also IoT. Well, actually, I do electronics, and then I figured out that I'm actually doing IoT when IoT started to be popular as a sort of a buzzword. And some of my projects, I actually bought a couple of pieces of kit I've done. Some of them are being commercially used in Britain. I'm not doing business in Slovakia. So I'm going to start kind of with my basic device. So this is a very simple device I've designed. This is a Atmega Arduino compatible board which has a temperature sensor on it and I don't know why I didn't bring the finished product. Basically, this is a CT. This is an energy monitoring kit. So this is a CT. It's called current transformer. More of you know this. This is basically clamped around the phase, the AC wire. This is connected to this wireless unit like that. So you can have 6 of those. It's using 433 megahertz spectrum to broadcast the information about how much electricity is used in individual phases, plus it's broadcasting its current battery level and the temperature from a DS18B20 sensor. It's using 433 megahertz spectrum, so when you use an Omni antenna with 0 dB, you can get about, well, maybe 200 meters, 300 meters of a very good link quality. So you can have multiple of these around in flats, houses, what have you, and you can have one Raspberry Pi with a receiver, which is based on RFM2 Pi module. So this is an energy monitoring, open energy monitoring project. Do you know the project? It's called Open Energy Monitoring thing. So this is based on that design with a different radio and different antenna. So this is receiving the information and storing it in the local database. It's a SQLite database. And then if internet connection is available, then it syncs the data to the cloud. If the internet connection is not available, it just buffers the data. Once the connection is restored, it just flushes the data and frees up the database locally. So this is just a dumb device, which is just kind of a gateway of the data to the internet. There is a new iteration of this unit. So this is now commercially being used in Britain. So it's used in a couple of places, in a franchise business and a couple of different places. We are gathering the data, we're presenting the data to customers. They're doing their own analysis. We're not doing analysis. Our customers are doing analysis. We're not in a business of doing analysis of big data because we don't know how to do it. That's one of the points of the discussion I would like to open. If you have lots of data from sensors such as temperature, energy usage, humidity, what have you, number of people moving in a hub, I don't know, number of cars coming and going, whether you have any type of big data analysis framework or anything that you use to analyze data. I don't know how to do it. I know that there's Apache Spark and whatever. I don't know how to use it, and that's why I'm not in the business of this. So basically, if you want to talk to me about energy monitoring, temperature monitoring, humidity, Arduinos, Atmegas, ARM, ISM stuff, Wi-Fi, 433.6.868 megahertz stuff, please do, because I'm very much interested in it. The whole solution is technically proprietary. Practically, there's nothing interesting really. It's SQLite here, lots of Python code, MySQL on the server, some Mongo stuff on the server, lots of PHP stuff on presentation layer, lots of own Python code. There's no magic. There's, we don't use framework like you provide because it's difficult to understand and it takes a lot of time to implement. So we use REST, we use JSON. That's it. This is, for example, the module for BeagleBone Black. Is the same thing, 433 module. There is RTC on here. RTC is right there with a battery, so we know the current time. You don't have to have access to the internet to sync the time. There is a socket for 3G modem here, so you don't need Wi-Fi or Ethernet. You can just use 3G stuff. And there is a space here to use a Modbus to read data from industrial energy monitoring stuff, like the electricity monitors, electricity industrial units.
Modbus or MBus?
Modbus.
Modbus, not MBus.
I don't know much about it. I've only done the design of the board, and my colleagues done. So I'm using this part of the board, and he's using that part of the board. So everything is using our serial interface. So all the data from the sensor, from the RF bit, is processed by the Atmega Arduino stuff, and then shown to the serial interface to Arduino. To BeagleBone or Raspberry Pi. Now, so on this module, I told you when you're sending data every minute, once a minute from all of the sensors, so that's 6 types of information plus battery, which is 7, plus temperature, which is 8, plus a beacon, which is a health check type of beacon. 6, 7, 8, 9, which is 9 pieces of information every minute. The battery lasts up to 3 years. Now, that was my first bit. I do my board design in KiCad. I produce boards through dirty PCBs in China. It takes about 2 weeks to deliver. It costs about $10 per board, per 10 boards to make. Farnell is used for parts, BGKey, SOS, and TME. Boxes are usually just a plastic electricity, stupid boxes. Antennas are made in-house because the ones you buy from China are just total shit. Now, the second part, which is important, and I need some sort of feedback after I say this from you, from potentially all of you. So I want to build an IoT infrastructure in Bratislava, and I want to build it on LoRa. Who heard about LoRa? Please tell me somebody heard about LoRa.
Not LoRa.
LoRa.
LoRa or Mora?
LoRa. Long range. So LoRa is.
We will be in the competition.
You will be in the competition. Great.
Yeah.
And you're from what kind of company?
Orange.
Orange. Great. Orange. Good. Now LoRa is a technology which is basically a transmitter or one-way or two-way communication technology, which is using 434 or 868 megahertz frequency spectrum. In Slovakia, it's safer to use 868, but also 434 can be used under some circumstances. Now, LoRa is a special way of transmitting data, which is used for a very low throughput. We're talking bytes per second, bytes, not kilobytes, nothing. It's bytes per second. Or in kind of in that area. But the range is very, very long. So when you have a device which has a 20 dB output, 100 milliwatts output, which is quite low, and you have a omni antenna like that, which is just a piece of wire, the range in urban areas is more than 2 kilometers. So this is urban area. So I'm talking about we're here, and the range goes all the way to the other side of Danube River, with that antenna inside this building. And on the other side of the connection, you've got the same antenna, which might need to be a little higher, but sort of we're talking about 2 kilometer range.
But it's not two-way communication.
It can be two-way. However, the project I'm trying to kind of kick off here is to create a network of gateways, which is in my head, or in practice, this is actually LoRa. So in practice, what you see here is in the box, in a plastic box with this on top of it, and we have 10 of these in Bratislava, and we cover the whole of Bratislava and all of the IoT devices which support LoRa to the internet. So when you have this, you don't need infrastructure. You don't need Orange, you don't need telecom, you don't need any other 3G network provider, you don't need Wi-Fi, you don't need anything to start measuring and collecting data from your sensors. Now, the cost of this is 50 euros. The cost of a box and antenna is another 10. Beat that, Orange. And if we pull together, if everybody gets one device and installs it at home or somewhere they have access to, preferably high up, we can have a simple piece of software which will be getting the data from the sensors, pushing them into the local database, and pushing them onto the cloud into one database. We can very easily create an API to this database, and using that API to access the data from our sensors. This is sort of my initiative, my idea. What I want to put into this project is my knowledge, my design, the boards, the parts. Everybody has a Raspberry Pi. I can provide antennas. I can provide know-how, all the technology. We can come here together. We can meet here again in 2 weeks' time, and we can put the things together in one evening. We can flash the Pi. We can build the software and do stuff. and have the network up and running in 2 weeks.
At the beginning, you thought that the throughput of this communication is quite low.
The throughput, yes.
The throughput, yes. So now imagine your network,
Yes.
about 10 these devices. How many devices can communicate with this throughput?
I don't know.
These
I don't know.
thousands.
But
You
there
should
is
put controller on top of it. You should have a clear design that you should make a border between you should need radio controller which will manage this communication, not to overload the network from stupid application. On the other hand, you should really need clear to manage the controller, control the traffic between the devices, which few of them, yes, of course, they can make communication both way, but a lot of devices will do only one-way communication. For this, you should store the data. Application is still not online.
So yeah, so
It's pretty complicated. It's not so easy like we're telling.
Okay, let's do it. Let's try it for a couple of hundred euros. It's simple, and it's ISM spectrum, so anybody can use it. It's
under some restriction.
Yes. So one of the restrictions is 100 milliwatts output power from the sensors, and which I think is easily achievable. So that's fine. And the other restriction is the time you spend broadcasting. So when you have a one-way communication and you have a sensor, you need to limit the amount of time you transmit. So, and that's usually limited to 1% of some time. I don't know what that is, but it's defined by the local telecommunication authority. We need to figure that out. I don't know what it is, but it's usually going to be 1% of time. So so if it's 1% of 1 minute, that would be a couple of seconds. That would be less than 1 second. But for less than 1 second, you can transmit one packet, which will definitely contain all of the information you need. So it will contain the ID of the sensor. It will contain the reading of the sensor. It will, you can put a lot of data into 1 or 2 bytes of data.
What about the security?
So because this is a one-way communication, the security from my perspective is not really critical in building a gateway network. So if you want to control the device, you can create your own controlling environment and controlling infrastructure. But I don't think this should be a part of building a gateway network. So I'm really talking about one-way communication. I'm talking about very, very simple service. We're not talking about, because two-way communication is difficult. It's quite difficult to do, especially when you need to, design all bits of the communication stuff. So IBM has done. There are a couple of layers of LoRa. So the most basic layer is actually one-way communication. That's how it's defined in the data sheet. The second layer, it's class B, is it? Class B, yeah. I think. That's a two-way communication. IBM has done a research with another company, and they do have a C library for two-way communication using a LoRaWAN protocol. It's called LoRaWAN, as in WAN. And you can implement the two-way communication, but because you just need to kind of separate that network from, you need to build your own private network for that. So if you have 1,000 sensors in Bratislava, you can just send one beacon to all of those 1,000 sensors. But this is not my aim. This is really a commercial stuff, I think, that needs to be properly supported.
Okay, I have two actually comments for this moment. So first of all, this project is already running, for example, in Amsterdam.
Yes, I know. So I got in touch with Guy.
Yeah. Actually, they have the router. I think it costs 200 euros.
It's not done yet. It's not developed yet.
It was on Kickstarter. Yeah, it was on Kickstarter. I
yes,
think.
It's just the name. Yeah.
Yeah, but so from my point of view, let's do something in cooperation with someone who is somewhere else already a bit further than we are. And second thing is that there are actually two competing standards. First is LoRaWAN, and second is Sigfox.
Yes.
Sigfox. The Sigfox is actually, I think it's proprietary protocol.
Yes, it's very much used though.
From
It's
France.
closed. Important is closed.
Yeah, proprietary.
Yeah.
It's developed in France.
Yeah.
But currently, I think several weeks or several months ago, the whole San Francisco was covered by Sigfox.
Okay.
The whole Spain, the whole
Spain
Britain,
is already covered. And
whole.
Italy.
We are talking about whole country.
I know.
So therefore,
it's very easy and cheap to do.
yeah.
When you have a provider like Orange. When you have
But the question is that which standard will win. So whether to go with the LoRaWAN or not. Actually, there are some benefits in LoRaWAN I see. The throughput in LoRaWAN is much higher than in Sigfox.
Okay.
And of course, another benefit is the packet size. In Sigfox, the packet size is, I'm not sure, 16 bits, something like this, 12, 16, really small number. In LoRaWAN, it's not limited that much.
Yeah, so the radios I'm using, that's limited to 255 bytes. Is one, but that's not limited by the protocol. It's limitation of the chip.
Yeah.
So it doesn't have such a big FIFO buffer.
And now I have the third actually regarding the security. I think the security is one of the most important things. Cool. If you would like to have 100,000 of devices nodes in let's say Bratislava, local Bratislava network, you have to make sure that you will control only devices you want to control. That nobody will just catch the packet and so on.
I completely agree. So that was my very aim from the very beginning, that I don't want to do a two-way communication. So the aim is really to have a great gateway in terms of receiving the data and pushing the data to the cloud. So that means that if you're developing a sensor, or if you want to measure something somewhere, you don't have to think about the infrastructure. The infrastructure is already there. You only design. You only take the Arduino with a LoRa module and start broadcasting the packets, and the packets automatically appear in cloud. So you don't have to do anything, you just plug the Arduino in. So this is going to be very difficult to do. It's going to be very difficult to do that gateway bit, so you don't push bogus data into database, you don't crash the database, you don't overfit. You need to control that gateway middleware. But I think if you really want to do something with IoT, and we want to maybe get more people interested in doing IoT in Bratislava, this is quite a good technology to do. And exactly what was happening in Amsterdam. It took them about 2 or 3 weeks to build the whole network. So they bought hardware. They didn't design their own. They bought hardware for about €1,500 each. And I think they have 10 gateways. They have 10 gateways around Amsterdam, and they managed to cover the whole of Amsterdam with 10 gateways for a very low cost. We can do the same with, there is already hardware. I can provide the hardware and the design files and schematics, and I already have PCBs made. Well, I've got everything made. I only need, somebody who might be also interested to build a network and work on that software layer, and maybe on the backend stuff, on the cloud bit. So create a robust enough database, an API to the database, so people can access the database easily. If this is just completely mental, just tell me. But if somebody might be interested in this, just talk to me later on or now, and I'll be more than happy to put effort and resources into building something like this, because what's been done in Amsterdam is amazing. I love it. And I got in touch with a guy who actually developed the whole idea in Amsterdam, and we're in touch, we're communicating with each other, and they're really trying to find, well, first of all, they're trying to find a business model. What's going to happen with this network? We need to find a way how to sustain it. We need to find a way how to make money of it, or at least sustain it. It needs to be it needs to run, it needs to be robust, it needs to be used. The other thing is they're looking for people to develop sensors and to develop ideas how to use the network. So they don't want to be in the business of building networks. So they only want to provide the platform. So even if you get in touch with Gardner, whatever his name is. So if you get in touch with him, it's really about how we can benefit in terms of not creating infrastructure, but creating services around infrastructure. And it would be so much easier for so many people if the infrastructure is already in place to start building services around it. But I'm a little afraid because many telecom providers will start doing this because it's very low cost and it's a very, very, very good addition to their portfolio. So it's not just, I'm sorry to take it as an example, but so it's not just Orange. It will be telecom. It will be all the Wi-Fi providers. It will be, I don't know, a railway, because they already have physical infrastructure in place, and building a new network on top of physical infrastructure you already have. It's very easy. It's very simple. It's just a device which telecom will be probably buying for £10,000 or euros or whatever. We have that for less than 100. So they will be buying that for £10,000 and putting that on the railway and poles and next to the BTSs on the rooftops, and they will create a network.
Screw that.
Huh?
It doesn't matter. Screw that. Just make it.
Yeah, it doesn't
for
matter.
geeks.
I'm just saying that
Make
it's going to
it for
happen.
geeks.
So it's going to
Doesn't
happen,
matter.
and I would like to see alternative which is free and completely open for people like us.
Do you know about some legal limitation for building such network?
Yes.
Not officially. I think you can tell us more. But as far as I know, part of the spectrum are part of the ISM spectrum, which is industrial something band. It's a spectrum which is used for wide use for research and industrial and lots of different uses, but it's not limited by a license. I don't think so.
Okay, there is not issue with the license. Okay, it's kind of the free spectrum. You have clear technical limitation, what you can do and what not in terms of the transmission and the powers.
Yeah, the power.
You should immediately forget only speaking about milliwatts. Milliwatts are not important in the area of the radio. Important are dB, dBm, dBi.
Well, dB. I'm talking about dB0.
Yeah, yes, because you are still everything is changed immediately with the kind of the antenna.
Yes.
If you can use today, there are primary use omni antennas in this LoRa. Next steps are sectorial antennas. Second version now, everyone in LoRa world is waiting for version 2 from Semtech. I think is the chip vendor.
Yes, Semtech.
Or Semtech, the primary company which came with the idea LoRa, and they are trying to make business on their chip and giving the idea free for the people. Okay. Come back to these legal issues. You can install immediately when you install some transmitters, and especially if it's kind of not the BTS but the gateway. You're in tricky situation because you are transmitting some energy, and you are not so far from on one side 2G, on opposite side from 3G band, and it can be issue. You should take care of this. Technically, you should manage everything should be perfectly. It's few megahertz you are far from these bands. If you are doing something at home, small mistake in the code or in the sending some values to the register in the Semtech chip, and immediately guys in the car, it's in front of your house and knocking on the door with invoice to pay.
For the whole of Slovakia.
No. The operators are measuring their bandwidth. We know immediately if somebody is transmitting in our bands, because we have problems with the quality of the communication, and all operators, we have teams split through Slovakia which are looking for any problems in the network and trying to optimize the network. If they found something, immediately to telecommunication office.
So,
sorry to finish. Problem is starting if you have only one antenna, it's not issue. But if you have more transmitter in some limited area, there are hygienic limits what you can transmit in some specific area.
Yeah.
Also, if it's free band, you should respect some another limits which exist. It means that to make some installation, you should think 2 times what to do and which place, which time.
So this is still an issue when you're transmitting. So this is every individual's responsibility.
Yes.
This is not a responsibility of what I'm trying to do. So I'm talking about purely receiving the signal. I'm not transmitting anything. It's just a pure receive-only design, which can use whatever gain antennas. You can, it can be massive antenna, but because it's only for receiving and hopefully not reflecting lots of stuff, you're not limited. You should not be. I'm not aware of any laws or any limitations in whatever terms when you're receiving stuff. It's like having a TV at home or something, or a radio. It's just a receiver.
Receive you can anything,
so
you can communicate to another.
So with a transmitter or with a sensor, it's a little bit tricky. So first of all, you need to really make sure that you're using that specific megahertz spectrum with the bandwidth which is allowed in your country. So it's not just the center frequency, it's also the bandwidth you can use. So that needs to be investigated. That needs to be, somebody needs to check that.
868, this is only some central band, but you have a few channels around it which are used with different powers for different purposes in the communication. There is clear specification for the Europe. It's not only for Slovakia, it's Europe, but if you will go to Asia, something different, US, I think 915, and in each part of the world you will find something different, what is not nice, but except 2.4, which is somehow harmonized through the whole world, all another is depend from the part of the world where are you located at the time.
So it's I would say that it's fairly safe. I'm doing it, so I'm just asking whether somebody else wants to be a part of it. If not, I'm fine. I'll just build like 2 or 3 of the nodes and start playing with it. But if somebody has ability to put another gateway somewhere else and donate their bandwidth, their internet access, and care about the node that it's up and running and it's being used, and maybe we can create a statistics of which gateway is receiving the most data, and you can do lots of different community stuff and get people more interested. Maybe Orange will come to us and try to, or somebody else, say, well, let's try
I'm waiting
this.
for gateway that we will receive. It's already ordered.
It's good.
We have already ordered gateways.
Well, one gateway is already up on my place, so it's covering. Can we show a Google Maps here?
Where's the gateway?
Huh?
Which street?
Slavin.
Okay.
Well, it's middle of
Umbrella coverage.
So it's umbrella coverage basically for the whole town, but I don't want to rely on one gateway. So one of the gateways, that's Slavin, and one of the gateways here. So this is the top of the hill. This goes down. This is the main station, the train station. So I was testing LoRa. That was just a receiver where the arrow is. I was testing transmitting at 100 milliwatts with this is basically what I had in my hand, with that antenna. That's a quarter wavelength antenna. And I was staying right behind the main church, and there was still a pretty good signal. It's over the hill, through many buildings in a very highly dense area in the old town, and there was still a signal. So I think that I'm probably covering about that much. And probably that much, I think, because this is another hill here, so I don't think I can go over it. But I'm pretty sure this is covered. If you have the sensor outside. If you have the sensor inside, I don't know. It needs to be tested. I was walking around the town, and pretty sure I can tell you that it definitely works all around the whole town. So if we have like 5 of them, we can pretty much cover 80% of people in Bratislava. If we have 10 of them, we can probably cover like 95%.
Bratislava is between 10 to 20 gateways to cover deep indoor.
Excuse me?
To cover Bratislava deep indoor, Bosway communication need between 10 to 20 gateways on the right
10 to
position.
20. Well, that's brilliant. 20 times 100 euros. 2,000 euros. And I think we can just chip in and do it. So with the sensors, if anybody's interested, I can show them. I can give you the boards. You can play with it. It's Arduino compatible. You just need to buy the LoRa module because it's quite expensive. It's about 10 euros, which is quite a lot for a temperature sensor. So you can build it. You can program anything with Arduino IDE. That's the compatible header there with the serial interface and the AVR programming interface. It runs on batteries. You got the 2.5 volt reference, so we can measure the battery level. You got 2 inputs for the battery, so when you unplug one battery, you can plug in another one, and then you don't have any downtime. It supports a nice little thingy display, which is e-ink. So the battery drains battery about will probably be not 3 years of battery life, but 1.5 years battery life. And what else? And you've got the temperature and humidity sensor on there, which is STH21, which is quite precise one, and it's a very nice one. Well, that was my input. Thank you very much.
Good idea. Thank you very much.
Maybe one comment to the LoRa. The industry is waiting now for Semtech guys that they will finish their version 2 of the chipsets, and the standard is written, of course, because the chipsets are under constructions. The main feature will be geolocalization. That is, you can imagine the energy what you need for GPS or another type of modules to receive the precise location. But here, in the cooperation with the network, the module will be able to identify the positions and to tell it for very extreme small energy. This is nice on it to run. And this should be Q1, Q2 next year available.
Well, we can upgrade the hardware very quickly. It takes about 3 days to change the schematics, and about the rush order, which is 50 euros for 10 boards from China, is about 10 days.
I don't know details, but I know, okay, hardware is one side, but there is some interaction between the network and the module. It should be Bosway communication. This is not work. You cannot send the info and waiting that somebody will tell you the info only.
Okay.
But it's still better for the energy for the batteries to use the GPS module. They show the Semtech guys already showed first application with bike to monitor the bikes in the towns in Grenoble. I think they are from Grenoble, and they were done the first pilot of Orange Group in the town.
I think the technology is really amazing, because if you imagine that you can come to this pump and you have just the device here, you can just bring it here and start measuring things like light levels. You don't need any type of infrastructure, you don't need Wi-Fi, you need whatever. It's just it just works.
In Czech Republic is already running, and some, I don't know where, I read that they are, I think it's guys from České radiokomunikácie. LoRa Sigfox is in T-Mobile in Czech Republic used, and they are giving the price per one sensor for communication yearly is around 700 Czech crowns, which is Which is how many?
Well, that's
20,
about
it's
20
pretty-
euros per
20
year.
euro per
sensor.
year, which means that close to €2 monthly.
Okay. That's
Okay,
a
question,
lot
what
of
is the
money.
business behind? Question is what's the behind, but this was unit price per one device. I can imagine the packages for 100,000 devices. What does it mean?
It's not easy to do because you need to deal with a lot of throughput data. You need to deal with the backend side of things. You need some.
They are giving also the backend that there is.
So that's what I want to do.
control.
I really want to deal with the whole, the whole bit. So the only thing you need to do is, to have a predefined packet type. How the packet is going to look like and how to slice it so you can assign specific information which will broadcast it to a specific person. So when you come to a cloud API, you need to know how to find your data which was received by a gateway in that cloud. But we can do that. We can do that in a couple of minutes, on a meeting, if somebody's interested.
First, I have one idea. Let's make a workshop, like a technical workshop, so we will see that how it works, how to program it, and so on.
Okay.
I think that there will be quite many volunteers that will be able to go into it because the price is not that horrible. Even if the project will completely fail, it's not a problem. I think to invest just few euro. And then the second phase is actually the business model, and this is, I think, the critical part. Yeah, because technically we can solve anything.
So which part is critical?
The business model. Business.
The business model.
Business is a problem. You need to get, as you mentioned, the network has to be sustainable. You need at least some funding, and the business is a problem.
So that's the same issue the guys in Amsterdam are facing. They have everything working and it's being used. I agree that the network needs to be sustainable, but also I don't think that we as a community, as specifically for this very specific project, I don't think it should be a strictly commercial-based activity. So
that's clear, but at least you need to get some money so that the network will be sustainable, so it will grow, as you mentioned.
Yeah, absolutely.
Perhaps regarding the Sigfox, the network, the competitive standard in this area, San Francisco, the town hall now is completely, the whole San Francisco area is covered by the Sigfox, and the town hall initiated a project that it will fund any project that anybody will come and will show the people in the town hall that what can be done with this Sigfox network. So if you have, for example, some, let's say, I think in Amsterdam they have this project of it's a crowd sensing that what is the temperature in the city and all these things. So
active citizen
might be there are several of this project. So for example, this is one application, and this is funded by San Francisco Town Hall. So this is a bit different. That the situation is different, the conditions are different than we have. So one thing is the technical stuff that we can, I think, solve quite quickly, but because you have the knowledge and you will just share it. But then the business model and then the framework, because currently don't have any framework. So for example, Bernie has actually the framework. The question is that there might be pretty many of such frameworks, and you need to match something like this. So it will be very easily to use, very easy to maintain. For example, as Bernie mentioned, there is the device maintenance or device management. There is the auto discovery on all this stuff. So the question is that how is this compatible? Or perhaps there is some other framework. So let's don't think about something completely new and build from scratch, but let's utilize something.
I would definitely recommend to use the fireware as backend, the software for the service.
Absolutely. Yeah, I agree. Well, the only question is whether somebody has knowledge to implement this and then support it. So I already have a business in Britain, so I already have the infrastructure. But if we want to build something or use something else, let's do it. But somebody needs to know about it. Somebody needs to be able to support it. So, and also it needs to be scalable, I think, because we can do this in Bratislava in 2 weeks, but then we can create the hardware and somebody all around Slovakia and Europe can do the same thing, and we can provide the backend to all of these devices. So if you have all of a sudden when you have 10,000 sensors in 2 years time using the network to upload the data, that infrastructure needs to be really robust and scalable. So I think that's exactly what you say when the sustainability and the business model comes in as an important factor, because scaling is hard. Scaling is difficult at that level.
Not that hard.
Scaling is hard. Scaling is really hard.
But there are already some mechanisms we can utilize. We are pretty much where we can do.
Scaling is hard. I'll just. It's really hard.
But it's doable.
We're talking. Tens of thousands of inserts into database. At the same time, it's real time. And it's
I
hard.
understand, but it's still doable.
It's doable, yes, but somebody needs to understand it. So when you have a limitation of a framework, it might become limitation at some point.
That's why
It deserves to be designed well.
Yeah, I mean, it needs
I
to be
think
designed.
this is if this is going to be a sort of a joint initiative of many people, and I believe we have more people from interesting companies here and who can. Who know how to get resources in some way, whether it's time or processing power or whatever, or cloud storage. I don't know. It's doable.
Okay, so as far as I understand, you have already a package
So
that you can just provide. Hey, if you're interested, this is the package. And perhaps we are missing some kind of instructions how to make it work. So it's very easy to deploy, I suppose.
So my idea, in practice, how would this work is there is a workshop, let's say in 2 weeks' time. I bring these, but they're not populated. They need to be populated. They need to be soldered on. It's easy to do. Maybe people would like to do it by themselves, or we can do it in Hack Lab or the what's it called Progress Bar or somewhere else. So I can bring the boards, I can bring the parts. We need to get the modules, but I can get them from China quickly. So we will get this, and this is everything. You can plug this via a serial interface to Raspberry Pi or BeagleBone Black or anything. The software is easy. It's really just a couple of 100 lines of code. That's easy. I can upload it on the GitHub and just create a very, very simple, cut and paste this into a Linux terminal, and it will just work. And in the meantime, we need to provide the backend stuff. So something that would synchronize data from here to the backend. That's also sort of easy to do. It's already done. I can provide part of code which provides this. So in practice, you'll get this. You just plug it into the Raspberry Pi. You would put it in the box. I got a 3D printer, so we can print some sort of a mounting something into a plastic box. We'll, get the antennas and you'll put that on the box. That's easy to do. That's already, done before many times. And you will just run Ethernet cable with a PoE and plug it into your router. That's it. That's what it is.
So you don't need your own database on this place?
The only database is on the device in case your internet connection goes down. So there's a local database which buffers the data, and once you've got the database up, you just push the data onto the cloud and free up the space on the device. And this device can probably store about 4,100,000 years of data if it's unplugged.
So you don't need any permanently running server or anything like that, just the Raspberry Pi and internet?
No.
Internet connection.
UPS
Do you have any protocol which will communicate with
I'm sorry.
Do you have any protocol or anything which will communicate with
Well,
this?
Frame at least.
I
Is
mean,
it designed
I
or-
just use JSON and HTTP. It's just most foolproof, and the Python libraries are really well done.
I don't expect that protocol to contain encryption or something like that, but is there at least some authentication or something like that?
We can
You
design
know, the
whatever we
proof
want,
that
but I think
the data from the source is original data, it's not made in the middle or something like that.
Well, for the data transmission from the gateway to the cloud.
No, from the device to the gateway.
Yeah, well, so that's something we need to agree on. You know, we need to kind of come up with a packet. It needs to be a very small packet, so the transmission time is very short. So I suggest something like,
MQTT.
I don't know, like 4 bytes or something.
Yeah,
And you can put a lot of
I
data
mean,
into 4
you know,
bytes.
it's just in no time there will be someone who wants to fake some data.
Yeah, well, so that's what I was talking about as a middleware bit, that it's going to be quite difficult to distinguish between the legitimate data and
Yes.
non-legitimate data. So we'll need some kind of a CRC checking,
At least
maybe
MAC, you know.
Mac, something.
Okay, that's a question for a workshop, I guess.
It's a lot of
This
work.
would be
I'm not
the
saying it's
business
going to be
limitation.
easy, but it's doable, and I think it might be fun.
Yeah, sure.
Because then you have a big data of lots of sensors and lots of information.
You don't know nothing about.
You don't know nothing about it, but you do have a real data.
Yeah, sure.
That's interesting. So we can create a wiki page where we say, well, okay, so we got this board. How do I connect a PIR sensor to it, or how do you connect? You know, how do you measure a light, the light levels in your room?
Actually, it could be a very nice introduction into communications for any wannabe.
So yeah. So my input is there and here. If we can kind of kick this off through the mailing list, or if somebody wants to create a new mailing list just for this specific project, that would be quite cool.
Go ahead.
But I'm here because I'm limited by time, so that's why I want more people to be involved. So the actual work needs to be done.
Great. Again, thank you. It was really interesting.
Thank you.